Hi PXers, we're here at PCIM 2025 in the YAGEO booth, and I'm sweating over here, and that's because we're running 120 amps through each of these boards. Why are we doing that? We're here to talk about power inductors, and to help me, Simon, thank you very much for joining us.
Hey, good to see you again,
So
Elliot.
what are we dealing with here? What have we got here?
Well, see, one thing is we can talk about how our product is better, but I think one way to do it best is to just show you. So
Okay.
here we just have 3 different examples of how our new Nanomet inductors can actually perform significantly better than the traditional ferrite or metal composite types of inductors.
Can I stop you right there? What is a Nanomet inductor?
So Nanomet is basically a new material that allows us to really make a smaller core size by pressing it into a different shape. So you have very small particles with this particular material, and that allows us to have much higher permeability on an inductor core.
So at the end of the day, we're talking higher permeability. What benefits does that pass on to the engineers at home?
Well, with the higher permeability, you can have a smaller core size, but you can also have a wider temperature range. With this particular material, you do have soft saturation, similar to what you would have with a metal composite inductor. So that means at these kind of current levels, you don't really have to worry about too much about your saturation curve. With ferrite, typically it's very temperature dependent, meaning at higher current levels, you have higher temperatures, means your saturation curve is going to change a little bit. Now, with the Nanomet material, you have soft saturation, so that's one huge benefit right there. But then also with the smaller size of the Nanomet material, that means you also have less copper inside of the inductor, meaning that you reduce your copper losses as well as your core losses in compared to the metal composite types of inductors.
Okay, so where we are right now, it is hot. I can feel the heat coming off of this right display and not the one on the left. How is that done?
Yeah, so because this one is running so much more efficient, we have reduced the losses in this particular Nanomet section significantly. So here you can see that this is only running at about 45 Celsius, while this one here is significantly hotter at about 70 Celsius.
Yeah.
So just seeing the temperature difference, that means also that the power supply is significantly more efficient, because running cooler shows us that, hey, there's probably not as much loss, right? Loss turns into heat. And this is one of those great examples that as we start having more and more of those AI servers coming out, they want to start using this type of technology because there's so much power being consumed with all these different types of GPUs. And this would be the solution that they should be approaching.
Amazing. So at the end of the day, this is a smaller form factor with a larger inductance that you could achieve higher current ratings in a smaller form factor.
Exactly. So the best of all worlds.
Amazing. Okay, to all the engineers at home, when we have a new innovation like this one from YAGEO, often there can be technical difficulties with the first sort of run-throughs when we're getting used to this technology. Is there anything that we need to know as design engineers at home to integrate something like this into our next board?
Well, when you start looking at the Nanomet, you can see it's a smaller form factor, it's a smaller case side. We have all the same footprints that's already available for those types of inductors, so it's very easy to integrate. This is really a great technology that gives you the best of both worlds, so there's not really any drawback. So with that, you can easily design this into your applications and you're ready to go. And so you can already see the efficiency in the products that you're going to be building with the new Nanomet material inductors.
Amazing. There's almost no reason not to go from something this large to something that large. If you're already planning on downsizing and reducing the size, weight, and increasing the efficiency of your components, this looks like a great product to go with.
Absolutely.
Simon, thanks for your time.
Thanks for stopping by, Elliot.